All right. Hi, everyone in the Twitterverse or in the internet. My name is Becky Schnexer, and I am so excited that you guys are here to talk about field and expedition science and incorporating that into the classroom. I'm so excited, and I have so many pictures and videos to show you. I also brought a few of my friends from my professional learning network on Twitter, so you're going to hear from them in and out. I'm going to share their contact information at the end of this broadcast. So if you want to connect with any of them, feel free. They are amazing. I have Danny, Elijah, and Kristen on with us, and you'll hear from them a little bit later. But let's go ahead and get started. I want to show you all the fun stuff I have for field and expedition science. So let's see. Of course, this was working earlier, so it's going to give me a hard time right now. Here we are. Okay. Let's share this with you guys. Maybe. There we are. Okay. All right. So here we are. This is Mad PD. I'm so excited to be a part of this year. I've heard about it for the last, I believe this is the third year for Mad PD, but welcome to Mad PD 2019. I hope you guys have been able to join in on some of the other presentations today. I know I've seen so many presentations, and I am jazzed to kick mine off with all of you and my friends. My name again is Becky Schnexer, and I am a pre-K through grade 5 science teacher in Virginia Beach, Virginia, and I have been in the world of education for 13 years. I've made it a personal and professional mission of mine to elevate science and the teaching of science, which is incredibly exciting, and I can't wait to share all of this with you today. Joining me on this live feed are Elijah, Danny, and Kristen, 3 of my PLN on Twitter, who I am so appreciative and enjoy learning from every single day. I'm so honored, guys, that you guys are here with us. So let's get into it. Let's talk about field and expedition science. What does that even mean? Well, to me, it means authentic science experiences for all students, no matter what age they are. Field science is really just about being on location and collecting data or observations of some kind. And expedition science is really just the same thing, but you're working with a team or a group of people. Sometimes you're collecting the same information, but oftentimes you're divvying up work, you're coming together to complete a big picture of whatever you're studying. So either way, we're really just striving for authentic science experiences. So why should we do that? I know that's a question I get all the time. Becky, why are you doing this? Why are you going about science in this way? Well, I feel, and I'm not even going to say I feel, I know that students need to experience science and know that it's not just something that happens once a day when the schedule of the day says we have science from 12 to 12:30 today. But it's always happening, and it's not just something that happened in the past. We spend a lot of time sometimes in the science world talking about scientists that are dead. And they're great. They're amazing. We should not skip over them. They're the foundation of everything we're learning. I know I get flack for that all the time, but they're so incredibly important. But we also need to recognize and understand that science is happening all the time. Right now, while you're watching this and you're listening to my craziness, there are scientists in the field making discoveries, making observations, testing hypotheses, and you should be doing that too. Your students should be doing that too. Science is not static. It is dynamic and it's ever present. So we need to show our students by involving them in these authentic experiences, these fieldwork opportunities, and in expeditions with a team. So me getting started into expeditions was about, 2 years ago. I finally, a light bulb went off in my head, and I was thinking, you know what? I teach this. I teach that science is happening all the time and people are making new discoveries every day. But I've never actually been in the field. And it was kind of embarrassing, honestly, that I'd never actually done this for myself, but that's what I'm teaching. So I decided, you know what? I got to get myself in the field. I've got to go on expeditions so that I can test out kind of what I'm doing. Am I teaching it the right way? Am I on target, or do I need to improve the way that I'm teaching this? And really what I found was it was a bit of both. And I fell in love with fieldwork in the process. So let's take a look at some of the things that I learned and then how I incorporate that in my class. So, one of the expeditions I went on last summer was to the Peruvian Amazon. And a lot of what I learned was technical equipment use, field protocols, and the importance of teamwork. So, as educators, I know it comes as no surprise. We talk about teamwork and communication a lot. I feel like that's all we're ever talking about. You need to communicate well. You need to work with a team. You need to compromise. All of these things, but in the field, it was so evident why communication and teamwork is important, especially in the field. And I'll talk a little bit more about how I make that more of a reality in the classroom, but a little bit later. In this picture, you see one of the teammates from that field expedition in the Peruvian Amazon. This is Marshall, and he's collecting water samples from a thermal river system, and he's using scientific protocols that were relayed to us by our principal investigator, Andres Russo. This is a thermal river, which means it's really hot. That water is super hot. So you'll see Marshall here wearing special gloves to handle the equipment and even the water samples, and using specific processes while he's doing that. So, after being a part of this particular investigation, I started adopting these protocols. So, when I do water sampling with my students, now I'm not taking them to a boiling river like you see here, but we are going to be sampling fresh water or oceanic water. So, I started using the exact protocols that I learned in the field to make it a little more authentic. And again, I'll tell you specific stuff about that a little bit later. Here, you're gonna see, although you can see me in the far left with the white shirt, I look so enthused to be there. I really, really am. I was concentrating. Let me take a step back because before you go in the field, you have to participate in these briefings where you learn all about what you're going to be doing. You learn about safety in the field. You have to know the what, the where, the when, the how to do things, and your role within the team. So I started thinking about, well, how are we going to incorporate that in our field science and in our classroom? How is that going to look when I go on expeditions with my students? And hopefully they don't look like me over here on the left. They're going to be a little bit more excited. Or, you know what? Maybe I was just tired here. I don't know. But I know. I love that picture. I'm like, man, what was I thinking right there? I was concentrating, you know? So in the classroom, I make sure to kind of replicate that, and let the students kind of be in charge of what is it they're going to study, what do they need, what's the safety that they have to worry about, what are the protocols they're going to use when they're collecting their data, and it really starts to build their buy-in and then their empowerment. One thing that I learned too, this picture is Dr. Prasanta Chakrabarty from LSU. He's an ichthyologist and evolutionary biologist. He has in his hand his field notebook. And I realized, like I kind of knew this, but it was so apparent, the importance of anecdotal notes, and how prevalent they are in the field. I didn't know. You're writing. He literally wrote all of the conditions: the air temperature, the water temperature, the ambient temperature, any type of readings that he could get. His personal feelings. Was he hot? Was he tired? Was it humid? All of those things came into account. He talked about the weather a lot, the location, but basically, like everything you see, everything you feel, everything you experience is written down, because you have no idea what you're going to wish you wrote down later. Sometimes you'll sit down and you'll start thinking, oh gosh, what was the air temperature at that particular time when I saw this particular animal? Or how long did it take that spider to cross over that leaf? Or how wide was that rock that had the tarantula on it that had all the babies? All of these questions you're not thinking about when you're writing your notes. So you just literally write everything you possibly can if you need it later. Something else that was important in the field was the importance of pulling your weight within the team and communicating. You're going to get tired of hearing that word communication, but it's going to make a lot more sense in the end, I promise. But that communication piece was so important. Mostly, we found out how important it was at nighttime, because in the field, in the Peruvian Amazon, we found out at nighttime, this is Andres, our principal investigator, everything we worked on during the day, we handed off to someone else at night to study further. So if I didn't pull my weight that day, if I didn't collect the samples the way that I should, if I didn't collect the sample in the location that I should have, then I let my whole team down, and I lost a whole day of work. Or whoever made that mistake or slacked off, they wasted a whole day. And I think we all know the importance of time. So that was super important. And my students, in an investigation I tell you about later, they're going to find out in quite an interesting way how important it is to communicate and what happens when you don't communicate well. Um, when you pass off your work, like when I passed off water samples or images to Andres, I didn't get the benefit of standing next to him and saying, "Oh, so when I wrote this symbol, that's what that meant." He had to be able to decipher whatever I did that day. And if he couldn't, then again, we are wasting time. So there were all these little intricacies that made such a huge difference in our work. And it was super fun to kind of build those into my students' expeditions that I'll tell you about in just a few slides. So here, one of my main tasks in the Amazon was also to collect 360 imagery along the river, which proved to be quite challenging. Just imagine, you'll see the picture on the right. I'm hiding from the 360 camera, and on the left, I'm placing it, and then I go hide in that vegetation. We're hoping to track conservation and change over time with the images that I collect. So that meant I couldn't be in the images, and neither could my partner Wesley. So we ended up having to play hide and seek with a 360 camera, which can see all angles. So this was quite memorable because I often found myself in the throes of tarantula webs or hiding in rock crevices like you see on the right-hand side. Or even you'll see on the left, I'm partially submerged in water that's actually a little bit warm. This was tolerable. I'm standing in it, so it's not super hot, but it was warm. It was warm enough where I didn't want to stand there very long. So some of that is kind of the adventure aspect of it. My partner, Wesley, and I found how important communication was. One point during this expedition, we thought we were being stalked by a jaguar, so that was fun. So we had to communicate to one another, "There's a jaguar, start running." A funny story though, side note, it ended up being a hummingbird, not a jaguar. A little bit of a difference, but communicating the possibility of danger that we were going to hopefully avoid at that time was super important. And again, this particular expedition, we're in the jungle. There's no cell coverage. There's no Wi-Fi. It's you talking to one another, and you're working by boiling water. You don't want to fall in. So any potential hazard, you are constantly communicating to one another. So that communication just keeps creeping up. And our job here was collecting imagery. So we had to consult one another on the best place for those pictures. Another thing that I was working on in the Amazon was, again, this is Dr. Dr. Prasanta Chakrabarty from LSU. We were looking to see if there was anything living in this thermal river system. So I learned protocols that were different for working with ichthyology as compared to water sampling with Andres as the lead here. And a lot of this too, we had to talk about communicating different things. So if I caught something in my net, I needed to be able to articulate that to Dr. Chakrabarty to find out, is this potentially a new species, or is that just your everyday run-of-the-mill Amazonian tree frog that we didn't have to worry about? So we had to communicate that constantly. We also ran into a lot of poison dart frogs, which can be dangerous. I'm sure you've heard of poison dart frogs. So communicating that there's poison dart frogs to the right, don't go that way, or don't go up that waterfall. There's a big, huge tarantula there. You don't want to mess with that guy. That communication just kept coming up over and over and over. So I knew when I scaled this to my classroom, I was going to have to embed that in every single thing that I did to get the point across to my students, how important communication is, and give it a little more than just saying, guys, you have to be able to get along with the team, because we say that all the time, but what does that actually look like? And now I have something concrete to say or to simulate in the classroom and say, oh my gosh, here's the situation. What are you going to do? And they have to practice those communication skills. The other expedition that I went on in 2009, I'm sorry, 2018 was to Galapagos as a Grosvenor Teacher Fellow. And this was a completely different expedition. This was in partnership with Lindblad Expeditions and National Geographic. I focused here not necessarily on quantitative data collection. I was working on behavioral data, looking at behavioral observations of endemic species. So you'll see here my different encounters with Galapagos sea lions, beautiful and unbelievably red sand. You'll see that in the lower left side. The Zodiac boat that took me from our ship to shore several times a day in the lower right-hand corner. All of these, this was just a very different type of science and a type of field science at the same time. Most of my work here was behavioral observation and then using that 360 camera again, but this time to simulate, to make virtual reality and augmented reality experiences for students back home and hopefully to distribute worldwide so that although I can't probably take my third graders to Galapagos, I can certainly take them there with technology, with virtual reality simulations. Another aspect of expeditions that is super easy to put in the classroom are just maps, geographical awareness. This is the map of my expedition in Galapagos, and this sparks so much conversation, whether it be about just maps in general, topography, latitude, longitude, or just to show my students. I took this picture right here, and I can show them on the map. It gives them location for the pictures. It also sparks conversation about the number of times I passed the equator. We crossed 4 times. You'll see that sort of in the top half of this map. Or a lot of times the students will look at this and like, oh my gosh, why did you cross so many times over the equator when you could have just gone underneath island Isabella? And then we start talking about the logistics of and reality of traveling by ship. There's this thing called ocean currents. And if we tried to go under Isabella, we would have all been seasick and we would have wanted to be off of that research vessel immediately. So this is just another aspect of adding a little dimension to field science and expedition science that I absolutely love. Now, I've talked so much about my expeditions. That's great, but I know what you're thinking. You said you're going to talk about involving students. So why is she talking so much about herself? Well, my friends, here we go. How do we involve students in our expeditions? I have tons of photos and footage of my students. The first step in involving your students is literally get outside. It sounds so simple, but sometimes that's the biggest barrier for so many of us. Oh my gosh, bring students outside. I couldn't possibly do that. They're going to be running around. They're going to be yelling and all that fun stuff. But if you scaffold this the right way, they are not going to be running around like crazy people. They're going to be engaged as students and environmental scientists. So you'll see right here, it is so simple. You don't have to have a big plan in place, although if you want to have a big plan, go for it. That's the beauty of field and expedition science. You just need to go and try it. So, of course, you need to have an idea of what you want to accomplish by taking them outside. And you'll see on the left, these students, I literally just said, we're going to go outside and you're just going to document everything you see. So very, very simple biodiversity survey and getting them warmed up to anecdotal note-taking for the field. So these students got to decide as well, how am I going to document? And you can see some of them are using their hands to scale some of the things they see. They're seeing a lot of hermit crabs inside the water, and there's minnows here. And sometimes they're going to see some oysters and scallops. So that one student, you can see she has her hand out. She's trying to figure out, well, how big is that? She's actually later, if I took a video of this, the girl closest to you has her cell phone and she's going to take a picture. She's then going to walk behind the other student and take a picture of what she's observing with her hand visible so that she can then later articulate to someone else, oh, we saw a fish that was half the size of her hand. Here's the proof. So it was amazing to see that student voice and choice with very little directions. My direction was go tell me what you see. And it can be that simple. Or you'll see on the right-hand side, these guys, these are 4th graders that were studying watershed rehabilitation all year long. And they now were just in the water using a kick net, collecting macroinvertebrate samples, which are just invertebrates, so things like crayfish, snails, those are macroinvertebrates. They went and collected those samples, and now they're using ice trays to just and food containers to separate what they see, and they're categorizing all of those different macroinvertebrates. They might not know in this particular picture at that moment what those are called, but that's where I jump in as the in quotation marks expert and I say, "Oh my gosh, all of those are different stages of life for a crayfish." And I start inserting the vocabulary for them. Their job is just get out and go get something, and I will help you kind of piece that together. So you'll see, no matter what you want to get out of it, you can go big or you can go small. It's just kind of what your comfort is. Or if you're worried about getting all your standards in and you need to have something a little more scaffolded or a little more planned out, this works for that too. You just have a little bit more work behind the scenes. Let's take a look. The next one, so talking about plans, this is so I live in Virginia Beach. These are pictures of my students that I bring down to the Florida Keys, and we do coral restoration work with marine biologists down there. Now, this is one that needs a big plan, right? We're flying down to the Florida Keys. We're driving from Miami to Key Largo. I have to get them ready ahead of time. They have to learn those field science protocols. So this is a great example of, this one is well thought out. This takes months upon months to plan and get everything in place. But really, when you take all the logistics out of it, it's merely getting outside and exploring. Now, prior to this, I have to get plane tickets. I have to secure transportation and safety and all of those release items. But it's really just another way of getting students outside and exploring. So I use my class time right before this expedition to simulate fish surveys. How do you know what fish is what fish? How do you know it is a fish? What species of fish is that? What's the taxonomy of the fish or the invertebrates that you're looking for? What's the field protocol for being in the water with these different animals? And the students prepare that way as their pre-departure briefing. So that briefing where you saw me so enthusiastically paying attention to my principal investigator, I do all of that in the classroom and then bring them outside to experience it and to practice those field science protocols. And that's something that I took directly from my own expeditions. Here, I will tell you that, or warn you really, two things with field and expedition science. Number one, students are going to have fun. So prepare for your students to have a lot of fun, but also prepare, like you see in this picture, for a little bit of shenanigans. The student has chosen our sample bucket as his seat right here. But just be prepared for the fun and the shenanigans, because those are all signs of your students being engaged and buying in to what you're doing. I know this one, so I want to show you a really, really simple way to do field and expedition science. This is on our campus. We're lucky enough to have box turtles. And so the simplest place to start getting your students in the field, as you saw before at those water places, those were off campus. But this one, you can see the brick building beside it. That's my school. This is on our campus. Now, you might not have box turtles, but I bet you there's some worms on your campus, or I bet there are birds or bugs or even plants. Like, there's stuff at your campus. You might just not have been thinking of it in this way before. So just ask a question to your students. What is living in this area? And you can mark off something with a hula hoop. You can start small. What's in this hula hoop? And the first thing they're going to say is, oh, grass. You're like, okay, great. So get on your belly and look closer. There's dirt. You're probably going to see ants. You might, if you dig a little bit, you might see worms, like I was alluding to earlier. If you want to be super specific, you can say, okay, maybe we're not going to talk about just everything in this area. You can be specific and say, well, what plants are in this area of our school? And if you don't know the names of them, you don't have to be the expert. That's a secret. You can work on identifying those later. That's part of being in the field. You don't always know what you're seeing, but you can certainly sketch it or take pictures and identify them later in your, in quotation marks, your laboratory with your students. You can focus on plants, or you could say, you know what, today we're going to be entomologists. We're going to focus on bugs. What bugs are in this hula hoop area, or what bugs are in the playground, or this marked off area that you want to study. Or again, you can stay super general. When I'm with my kindergarten and my pre-K classes, I just say, what's living here? And then they will start drawing things, and I will start helping them build that vocabulary. Oftentimes, your biodiversity survey is so easy to do on your campus, and this is totally fine. It requires a lot less legwork than going to the Florida Keys, which is hours away from where I am, but it's going to yield fantastic results for your students. So here, with these box turtles, this is another shot from last year. These guys are second graders. I can use these box turtles or whatever I'm studying for several different grade levels. I just start scaffolding and making it a little more rigorous as they get older. So in first and second grade, we really just talk about what is a turtle. Well, it's a reptile. What makes them a reptile? What makes these reptiles box turtles? They also focus just on behavioral observation. So sometimes they're not even ready to say that it's a reptile or that this is a turtle or a box turtle and go into taxonomy. They're just going to tell me, what does it do? So we take 5 minutes, and that's a long time for a first grader, I know, but they can do it. They take 5 minutes, they sit just like these gentlemen are doing, and they just watch and they write down everything they see happening. The turtle extended its neck. The turtle walked away. The turtle hid inside of its shell. The turtle swished its tail. Whatever they see, they just write it down. And this is the quietest you'll ever hear a first grade class in particular, because they're so engaged and they've bought into this science. It's absolutely fascinating. So I teach them how to record every single thing that they see with this one particular animal. And then later they're going to articulate that to someone else, no matter what it is that they were observing. By the time they reach third grade, right now, my scientists that I bring out to this particular area on my campus where these turtles are, they're actually learning how to track and when they should track and identifying gender of these turtles. Actually, tomorrow, my classes that I see, we're going to start talking about, well, how can we track them? Should we mark their shell? Should we do something around their neck? Should we do something on their legs? How are we going to track these guys? And I make them responsible for figuring out how to track them and when we're going to track them. And I teach them how to identify the gender, but it can be that simple where you just let them go. What are you going to do? Here's the situation. You have to track these turtles. How are we going to do it? Or if you're someone that wants it a little more scaffolded, again, you can make it a lot more scaffolded. You can decide, this is how we're going to track the turtles. You guys are going to help me do it. I like the students to have so much student voice and choice that they really just run with it. And I let them run with it because I believe that that's very important in their educational journey. So that is super fun. The communication piece, though, back to that word, communicating what they're doing to someone else, whether it's someone in their class or their other teachers or the community as a whole. They just started a podcast and a blog. These science students. That communication piece is often neglected in science, whether you're doing a lab, field work, or a STEM project. Part of the scientific process across the board is communicating what you've done with other people. Oftentimes we forget to do that, or we purposely neglect that because we have time, like we've got to cover the next standard, we got to move on, but that's super important. So I make sure, especially after being on expedition and figuring out how important communication was, I make sure that I don't neglect that. So how do you do this on your campus? Maybe you have the most boring campus we've ever seen and it's completely covered in concrete. Well, we can work with that, I promise. Think about your campus. What do you have? Do you have a retention pond? Do you have a garden or grass anywhere? Mud will do. And you can make your own mud if you want. Dig up some dirt, put some water in it, and let's call it mud. You can investigate that. If your campus is like covered in concrete, it's a concrete jungle, there's nothing awesome about it, I'm so sorry for you, but can you see the sky? Because if you can, then you can do all kinds of observations with cloud types and atmospheric science. Does it rain where you are? Chances are the answer is yes. You can do so much with rainwater. And let's say worst case scenario, you have no retention pond, there's no grass where you are, you have no mud, you can't make mud, dirt doesn't exist where you are, you can't see the sky because I don't know, you're in a concrete block all the time, it never rains where you are. I bet though that you have garbage, and garbage science can be some of the most fascinating things that you study. Can you look through the trash? This is really gross, but the kids love it because they're like, oh man, we get to play with trash, everybody tells me not to touch it. Well, that's fine. Just put some gloves on. Let's do this. You can go through the trash and look at the things that are being thrown away. How much of it is plastic? How much of it is compostable? How much of it is actually recyclable, but you're throwing it in the trash can? You can do all kinds of investigations with trash if you have none of those other things to investigate. And there's so many other ideas. Just let me know that you have a big you have nothing to investigate, and I will give you 100 things that you can go investigate, and I will even help you with it, I promise. Okay, so if you have none of those things, and you have no garbage, like you're living in this fantasy world here with no garbage, that's amazing. Do you have any fish tanks or class pets? Because you can use those for behavioral observations. What are they doing? What do they look like? Where are they going? When do they eat? When do they not eat? When do they sleep? When are they not sleeping? These are all really easy things to incorporate field and expedition science into your classroom, even if you have very little access to other cool things or things that you think are cool. Now, my next slide, I'm so excited to show you because this is an example of what happens, the student impact, the impact on your students when you start incorporating this type of science instruction, this hands-on, this inquiry-based expedition and field science. These pictures have nothing to do with anything I planned. I actually had something completely planned for this science day, and my students, the previous day to the one that you see pictured, it had rained, it downpoured. So I'm lucky it rains here, right? So we can study rainwater. These students made their own field station. This was not at all my plan for the day. They stormed my room, pun partially intended. They stormed my room after the storm water that fell the previous day, and they demanded that they make their own field station, and they take the samples and they bring out microscopes and they look for microorganisms. They had already divvied themselves into teams. This was going to be the entomology team. This was going to be the water quality team. This was going to be the water microbiology team. This team of students was going to be in charge of collecting those samples and organizing all of the data. They came to me with this plan. Like I played with them. I'm not going to lie. For about 1 minute, I was like, no way, guys. Like, there's no way we can do that. There's no possible, you guys need to show me your plan. You need to show me like what is going to happen. What are you going to do here? But I doubt you can do that. So you tell me your plan right now. We're going to do what I decided I was going to do that day. But of course they came up to me and they were like, no, these guys, this is their team. This is their team. This is their team. And lo and behold, about 5 minutes later, they gathered it and they set up these field stations outside, all because they were empowered to do this. They felt confident and they felt the need to go out. They had an opportunity and they seized it, all without me doing anything. I think I held the door for them to go outside and collect these rainwater samples, but they made up this plan. And that is the big takeaway from incorporating this type of teaching. Your students are going to feel empowered to do science on their own. They're going to see themselves as scientists, and they're going to take it upon themselves to do this type of investigation, which I just think is amazing. They were on fire, and I just looked at them and I was like, oh man, I wish in third grade. And so you see second grades on the two pictures towards the right, and then fourth graders are on the left, and they focus more on water sampling and water quality testing. But I wish that in second grade and in fourth grade that I was that empowered. This is not at all the way I was taught. So it's super important to me that I bestow that upon my students. So I know what you're thinking now. I am very lucky. I have rain at my school. I have gardens at my school. I have all these things. But what if you at your school, you can't do it. You can't get the students outside because they're all allergic to grass and it's just terrible. Fear not, my friends. Let's look at some ideas where you don't have to go outside at all. So, if you can't get in the field, you can always take the lens of documentary films. You can simulate the field in your lab or your classroom space, or you can even use virtual and augmented reality. So, while I was in Galapagos, I told you that I was working on behavioral observations. So, one of the first things I did when I got back was show this video of a marine iguana fight. So, I'm going to show it to you, and then I'll tell you the challenge I gave my students. So, here's this video. No, that's not it. There we go.
All genetic information spelling out that a long time ago most movies were nesting on trees, like any normal bird builds a nest on trees. They're still doing that because of that information.
All right. So while they were watching that, their task. Actually, I didn't tell you this part. Their task was to write down what behaviors do marine iguanas display. And so when I was actually watching this in real time and taking this video in Galapagos, I was focused on those two iguanas fighting. Those are two males, and they are fighting for territory. It's about to be mating season, so you see some of these marine iguanas are starting to get that coloration on their body. Normally, they're just flat black or a flat brown color, but they start displaying their colors to attract their mates or their potential mates. So those two are fighting over territory, and there's probably a female involved. But that's what I expected my students to latch onto. What they saw a whole bunch of stuff during this video. So of course, it's obvious there's two iguanas fighting. So asking all kinds of questions. What's going on here? Blah, blah, blah. But what they noticed, which I didn't notice in real time, and until they pointed it out, was in the top where you see kind of the bluish green water, there are iguanas swimming. So you can look and you can observe that behavior. What does it look like when an iguana swims? They also noticed Sally Lightfoot crabs crawling all within the rocks, all around these two males that are fighting. They also saw tiny lava lizards going around and watched how the lava lizards were almost like an audience watching the iguanas do their thing and fighting. And then there's also an iguana in the top right hand corner that jumps and face plants into the water like a little clumsy guy. And so all my students are showing me and they're telling me all this, and I didn't believe them. I'm like, you're just making this up. There's no way that I missed that. But sure enough, they saw all those things, and they saw the one iguana off to the right snort out salt water, and that's how they have adapted to diving and holding their breath underwater for about an hour. Marine iguanas, they spit out, or they snort it out, really, the salt water so that it doesn't harm their insides. So after they watched this and they told me all this, and then they had to prove this face planting and all these other crazy observations, they told me, I wasn't sure where I wanted to go with the behavioral observations yet. They told me that they wanted to make a documentary film. And so they staged it, and I'll show you. It's hilarious. This is my crazy lab, by the way. So they staged their documentary film. They made a script, and they said, we want to be the marine iguanas. We're going to display everything that we learned there with their behaviors, their head nodding, their snorting out of water, their mating behaviors, the coloration that's starting to show up. And we want you to narrate it with a crazy accent. So Here's their documentary film. This is how they brought us all into the field with their behavioral observations.
Here I am, live from Galapagos Archipelago off the coast of Ecuador. My name is Becky Schnexer, a world-renowned scientist and
see they're nodding their heads
of endemic marine iguana species in Galapagos. Here, we have a giant colony already with their mating behavior. Do you see them nodding their heads, claiming territory and mates? They're also displaying their mating colors. Look especially at this iguana with the bright pink coloration. Never have I observed such a pink marine iguana coloration and very aggressive head nodding behavior. I'm wondering though, will we be lucky enough to observe them diving in the water and getting algae off the basalt rock formations? Oh, how lucky we are! Take a look at these marine iguanas gathering algae from underneath the water and then surfacing and lounging on those basalt rock formations. Continuing with that nodding behavior, this aggressive marine iguana is claiming his territory from the other male iguanas who wants to encroach upon his basalt formation. Let's see what happens when another male with brightly colored skin shows up. There we saw the mating aggressive behavior. What a treat we are in for here on these basalt rock formations. This is quite a treat to observe.
The best part, the very end. I need someone to fight me. But that's where this naturalist science, they had seen all these behaviors and they wanted to act it out. So that documentary film, the ability for them to do that, you could do this with any concept in science. If you show them whatever animal you might be focused on or whatever behavior, adaptations, the students will take it and run with it. I didn't particularly assign this, but in the future, you bet that next year I'm going to assign documentaries for the students to create. But this was just another example of them taking what they did, taking that observation and really grabbing a hold of naturalist science and behavioral observations and making it their own. You just need to give them the background knowledge and the wings to go for it. I know this is taking so long. I'm so sorry, but I'm so excited. I want to share all these things with you guys. This video, the very first part is me in Galapagos explaining to my students something that I just witnessed. And then the very end is how this is a different class. They took the same concept, the concept that I'll describe in this video, and then they tell the story through creating their own game. They invented their game to demonstrate this field observation, which was pretty awesome.
Hey guys, so we're on San Cristobal Island. I almost stepped on a lizard, but we are looking for red-footed boobies, which are only found on the perimeter islands of the archipelago. So we did find someone. They are the only boobies that will nest in trees, and so it's super special to see. It's really difficult to see their red feet, but I've been working on getting some 360 videos and 360 images of them, but I'm not quite sure we're going to clearly be able to see their feet, but there's some just below. There's one that just flew overhead, and there's also some magnificent frigate birds, which are trying to steal the food of the red-footed boobies as they get their food. The frigate birds they do something called kleptoparasitism, which I learned. Klepto, means to steal something. Parasitism is to benefit from something while it does not benefit. So they steal the food of other birds. They literally grab onto the bird and they shake it until it regurgitates, and then they steal its food.
Never. Thanks. I have nothing. I have it. That's it.
So those guys decided they were going to design a game where they had, some of them were those frigate birds, and they had big red gular pouches, and they decided they were going to use balloons. They were going to tape them to their chest if they were frigate birds. And if they were blue or red-footed boobies, they were just going to know that they were blue or red-footed boobies because they were running and getting the food. So they had toys of different types of fish on the one side. So the blue and red-footed boobies had to go get the food, and the frigate birds would tag them. And if they tagged you, then that meant that they were practicing kleptoparasitism and they stole your food. So it was fantastic to see them come up with that on their own just from these field observations. So did I bring my students to the Galapagos? No, I didn't, but they did get that concept and they were able to show it in a very unique way. So it was just like bringing them to the field. Here, oh gosh, did it again.
Hey guys, so
You don't need to see that again. Here, my third graders study geographical features and landforms, and I wanted them to experience caving because in teaching them about cave formations and different rock formations, I showed them a picture of me from college where I went caving with a professor. And I thought that was going to be good enough. Like, okay, you get the concept of here's my story about caving and all of that, but they were so into it. I decided, you know what? They're going caving and we're doing some field work in the caves. I can't take them safely to caves, but I can certainly transform my classroom into a cave system. So here you see all the students getting ready. They're entering the cave system with headlamps on their heads. Some of them had flashlights, but they had their field notebooks. And this was sparked all from just a picture that they were excited to see. But they wanted to for real go caving with me. So lo and behold, I did. This is Schnexer Caves, as you'll see on the top. Inside of my classroom, here's a sneak peek. I made 5 caves. I just covered the lab tables in paper and they had to go in. We turned the lights off. And every single cave in this cave system had a different data set within it. It had a different biodiversity. And that data I got from actual caves in Virginia. So what they saw in these caves were actually representative of what they would see if I took them for real in a cave. And to see if they would communicate and collect their data accurately, I had every single cave with different biodiversity. Only one cave had bats in it. So the next day when we're analyzing our data, if I have a scientist who put that there were bats in every single cave, I immediately knew they didn't communicate and they didn't accurately display or record their data. So going back to that communication piece. So they were diligent. They knew that inside some of these caves, they couldn't disturb the bats. So they had to communicate to one another. You have to duck right here. You have to stay to the right because all the bats are to the left. Building in that communication piece was super important here too. And it was an easy kind of scaffold to go in there. They were super diligent in talking about it, or super excited because they found the cave that had the bats. They were screaming bats. And so we would talk about if we were actually in a cave, would you want to do that? Probably not. That's not not the safest way to deal with bats in a cave. So here's another sneak peek into some of the caves that I had built. These guys are hard at work. You'll see student on the left, he's recording all the species that he sees. He has his headlamp. The girls on the top right are pretty excited that they found a tarantula or a large spider in this cave, and there's some scorpions too that are hanging out from the ceiling of this cave. But the following day in class, what they did in the day that you're seeing right here, they found out very quickly their data needed to be accurate, but I made them switch notebooks. So for example, the student on the left, his notebook was passed off to someone else in the class. And so the next activity where they were analyzing data, they were using someone else's notes. Just like I did in the Amazon, I had to pass off my notes to someone else. And so they quickly found out who was the most accurate and organized scientist in the group and who they wanted on their expedition team next time, because the scientists that were able to record accurate data and in an organized way ended up being the most successful field scientists. So this provided great conversation, not only about the logistics of being in the field, but being able to communicate and carry your weight within the teams. Some of these teams couldn't complete their mission in analyzing data over time for these caves because on day 1 of the expedition, they didn't have accurate data. And so the next day they came into class, they were no longer caves. They couldn't go revisit those caves. So if they didn't do their job yesterday, they wasted the entire time. So it was one of those really hard lessons, but it was also, it drove the point away that when you aren't accurate at collecting your data or communicating that with someone else, it totally throws off the team. And it goes back to that communication piece. This expedition was with second grade. This is probably one of my favorite simulations that I've ever done. I simulated the Boiling River expedition for my second graders because they study biomes. And so we were talking about rainforests. So I created in the hallway, all that blue tape is painter's tape, where those are all rocks that they have to balance and travel upon with all of their field equipment in their hand. And they found out pretty quickly that it's tricky not only to balance on rocks with being surrounded by boiling water, but doing that with a team and with all the field equipment on your back or in your hands, it ends up being really, really tricky and really tiring. So around the corner, if they make it to the base camp where they actually start collecting data, and I use the data that we collected in the base camp for over the summer with them so that they felt like, oh, these are actually numbers. You didn't just make this up. If they made it there, they were so tired and they were like, oh my gosh, what do we have to, we still have to do work? And I was like, yes, just think about being in the Amazon. Like, it was hot and we're sweaty and we're tired. But then that was just the first part of the day. You just made it to base camp. You haven't even started the science part of this yet. Now it's time to collect their data. So I took a video of their expedition to the Boiling River, and we sent it to Andres, and he loved it. So here's a little peek into how well, or possibly not well, they made it through the expedition that I had done over the summer.
Oh no! I almost made it. Did we lose an explorer?
I'm a goner.
Okay,
Perfect.
spread out though, because our friends need to get to the. You got to scooch so they can make it.
This is my favorite. His team member's dead, but he took the equipment from him. Science is important. Yeah, I got this.
I got this.
Oh no!
Oh no, another explorer.
We lost another explorer. Oh no!
Same scientist again. It's okay. We lost a team member, but we got his stuff.
What are we gonna do? Okay, you guys start collecting data. Start collecting data. Here we go.
All right. So sometimes, I can't bring them to the Boiling River, but I can simulate it in the classroom, which is always a treat, especially when it's character. You see a lot about their character and how they deal with these situations, losing a teammate, but I'll get their stuff at least. And finally, some of that, maybe you have older students and this won't fly with them, and that's totally fine. I get that. But what you can do in geology, I simulated some field work through these types of scenarios with different teams of students in fourth grade. That's when we do a lot of our geological studies. I provided each team of students with several maps. They had a geological time map, a geological survey map, so showing where different types of rock are in the state of Virginia. The geological time is just how old different parts or different rock specimen in our state are. And then the geographic regions of Virginia, because that's one of our social studies standards, is they have to know the geographic regions of Virginia. And they also have to know the rock cycle. So I gave them all of these things that they needed to use. And then I would throw a scenario. I had 5 different scenarios. I'm just going to show you one, I promise. And they had to interact with this. So their task is right here. Your field assignment is to collect metamorphic rocks from the earliest geological time period in the state of Virginia. Your principal investigator, Dr. Russo, needs a list of possible sites to investigate as well as justification for them. So not only are they worried, they have to use what they know about rocks and geological time and different regions of our state. They have to use all of these primary sources together, and then they have to propose it to their principal investigator. So then we really started talking about communication, where if you're on part of a team, there's always someone in the field that's in charge. They're your principal investigator. And so you have to propose things to them. You have to prove what you want to do, and you have to give justification. You have to tell them why you're going to do what you want to do, and it has to be good. You're talking to someone who's in charge of you, so you can't just say, "Hey, dude, we should go to Crozet, Virginia, because it just looks cool." Well, that's not how you talk to your boss. That's not how you talk to your lead investigator. So we really weaved in some of those intricacies of being able to communicate in a different way than we had in these other investigations. So worst case scenario, you can't get out in the field. You can't kind of do the little pretend simulation. You can certainly do a simulation like this, where it's challenging students to use primary sources, and it's interdisciplinary, and it's really working on that communication, which is so super important. Lastly, and I swear I'm going to stop talking, I promise, is talking about virtual and augmented reality. There are so many things out there that you can use to bring your students to certain locations. All of my 360 imagery I've turned into virtual reality tours for my students and published them on Google Poly. I used Google Tour Creator to create them. If you don't have your own 360 images, you can use Google Street View. People are uploading 360 images on Google Street View all the time. I have a whole bunch of Galapagos in there, and they have the copyright information at the bottom, so you can use their images, and it has their little stamp on the bottom, so you're not plagiarizing by using their images. And then Google Expeditions has stuff that's already preloaded, so you can definitely check those out. I've made some, and with the combination of things that are already made for you, you can bring your students to a whole bunch of different locations and have them study those or do observations just with imagery if you can't physically get them out into the field. And with that, in saying that, I would like to turn it over to my special guests who have been so patient and listening to me talk for like an hour about all of this. What do you guys think? Do you guys have any questions? Maybe? No?
I'm thinking.
Okay. You need to think. Anything? Kristen, Danny, Elijah, Bueller?
When you finish an activity, will you inquire with everybody? Oh, go ahead. You had a question, Kristen?
No, go ahead.
Okay, I was going to say afterwards, will you reflect back on them with what did you like about the activity? What would you do differently next year? What would you have other scientists do to tweak and improve?
Yeah. That's so in communicating with other people about what they're doing, a lot of times they are ready. They're like, oh my gosh, can I write about this? Can I put a blog post about this? And then I'll start prodding them with those types of questions to make it a little deeper, because they just want to tell you this is what happened. And then I, just like you were saying, Danny, I'll ask them, so what were your big kind of scientific takeaways? What advice would you give to next year's field team who are going to do a similar investigation? Would you want them to replicate what you're doing? Or do you have questions that you might want them to investigate next year, or to kind of help them craft their expedition for next year? I ask them those sort of questions to kind of get their wheels turning about thinking not only about what they did, but extending it a little bit further.
Excellent.
Yeah. Kristen, did you have a question?
I was just going to ask you, how often do you go on your expeditions, and how did you find out about them?
Oh man, great question. So this summer I go to Florida Keys every year, and that's through my school's travel program. So, so that happens every single year. A new group of students go down with me. This summer I'm going to Belize, Tangier Island, and then back to the Amazon. So backtracking though, the way that I found out about Galapagos last year and about the Amazon, I wrote a grant for the Virginia Association of Science Teachers. And I just proposed the idea that professional development can be a science expedition. And so I proposed that idea. Hey, what if I went to the Amazon, I studied field science and scaled it for my students? And that's where I got funding for that particular expedition. I just happened to know Andres Russo, who's the principal investigator for that, the Boiling River project. And so I wrote the grant, and then I quite literally, it's half joking. Well, it's not even half joking. It's like 10% joking, but 90% true. I invited myself on the expedition with my friend Andres, and he, after I told him what I did, he thankfully said yes, I could go. But that's how that one went down. Galapagos was so I'm a National Geographic certified educator, and when you do that, you have the option to apply for the Grosvenor Teacher Fellowship, and that's what I did for Galapagos. I applied for that fellowship, and then I was placed on expedition to Galapagos. So that's how those went down. To go to this summer, to go to Belize, I'm going with limited resource teacher trainers. So I'm really going down to train teachers in limited resource areas, and then I'm hopefully going to be doing some manatee research with an explorer down there. So basically what I do is stalk people on the internet, and I invite myself to do science with them. And then if they respond, I get to do science with them. And if they don't, then I don't. So that's kind of how that went down. Tangier Island, I am going with Chesapeake Bay Institute, which is sponsored by VIM, Virginia Institute for Marine Science. So I am just always looking for opportunities to get in the field. So that's kind of where that happens. I just hang out on the internet and look for opportunities.
No, that's very cool, and I love how you take what you learned and bring it right back to the classroom. So that's awesome.
Yeah, it's so much fun.
That is awesome. Becky, I have a question. I wonder how much of like the students' questions sort of guide their expeditions and like experiences at school versus how much is kind of prompted by you. Like, 'cause I know you mentioned a couple times that the students came up with their own ideas for like a project or for the day. So how often do you find that happens?
Oh man, so it takes a lot of work to get them there. So what they are really crafting great investigations, but it's all about the way that you go through it. So a lot of the times in the very beginning, when I first started doing this, it was mostly me, and I would do the teacher talk, the typical, like I knew what I wanted them to do. And so I was like, oh my gosh, I wonder how many praying mantises are on this tree in the playground. What should we do? And they're like, yeah, let's go to the playground and look up praying mantises. So I did a lot of that in the beginning of just the teacher talk. And then eventually, it took about a year, I think, of me really kind of scaffolding that for them and just modeling that kind of I wonder type of question or teacher talk really before they started coming. But that rainwater investigation came this year, and it came from second graders and fourth graders on the same day. And I thought they had consulted each other in the hallway on the way to class, because I was like, are you serious? The second graders just came in and said, can we go down and do this? And the fourth graders like, what? That was our idea. I'm like, okay, let's do this, guys. It's fine. But it takes a little bit of time, and it's very atypical to learn science or probably any subject this way. So they're just not used to it. But once you really do it a lot, they're going to start jumping on it and kind of going crazy with it. So in the beginning, a lot. And then as you get into it, a little bit less is mine. But sometimes I do.
Right.
Or sometimes I'll propose an idea and I'm like, I wonder how many praying mantises are on this tree. And they're like, no way. We want to know how many roly-polies are in the garden. I'm like, all right, touche. Let's go look at roly-polies today.
Right.
So I don't know if that answered your question or not.
No, that does. Thanks. I find that I found that quite a bit this year, more so with any of my other classes, that they were a lot more curious and wanted to like venture out a little bit more. So I was just wondering how you scaffold that and all that. So thank you.
Yeah, and then some classes are totally more into it than others. Fourth grade, we do that investigation where we go to freshwater and we collect macroinvertebrates and we raise trout all year. We raise these fish and we release them. So I do that trip, and same thing with the Florida Keys. I do those every single year, but every year the students are kind of interested in different aspects of it. Or like last year, they weren't really excited about going into the field, but yesterday I did that trip with this year's fourth graders, and I had to like wrangle them out of the water. I'm like, no, seriously, like we have a 4-hour car drive. Like we need to get in the bus now. Like stop collecting invertebrates. So it also comes in waves with students as well.
Yeah, cool. Thank you.
Any other questions, guys?
So what was?
No, your presentation was awesome.
Oh,
Yeah.
thanks. I feel like I just talked to nonstop.
So you're National Geo, yeah, I can talk. You're Nat Geo certified, correct?
Yes, yes.
So what was the process in getting all that done?
Oh man,
I didn't know that was even a thing. So
dude, I'm totally gonna send you some links after this. It's awesome. Kristen, have you done it?
No, I haven't, but I've heard you talk about it, so it's pretty cool.
Y'all about to do it this year. So you have to, what you do is you learn all about National Geographic's learning framework. It's amazing. I mean, you're going to read it and you're going to be like, oh my gosh, yeah, duh, this is amazing. So you learn all about that and then you incorporate it into 2 activities in your classroom. So, and literally what you're going to end up doing is taking something that you already teach and making it just a little better using their framework. And you teach 2 activities in your classroom demonstrating the added I guess rigor, relevance, the key aspects of the learning framework by National Geographic. And your culminating activity is a capstone video where you show the activity and you explain how it incorporates National Geographic learning framework. And then that gets evaluated by a panel and they talk about, you know, how well did you plan it? How well did you highlight the different aspects of the learning framework? And that's how certification goes. So it's really just taking the awesome stuff you already do and making it awesomer using the lens of being an explorer. And I'm a facilitator for the phase 1 of that. It goes into 3 phases. So I'm just really giving like the most abridged version of what it's all about. But it's amazing. Using that was actually one of the impetusi, I don't know which one's correct, for me to do more expedition and field science with students, just because that inspired me to go further. So
okay.
that's I'll definitely share that with you guys. I would love for you guys to join the National Geographic family.
That would be awesome. Yeah, thank you.
Cool.
Awesome. Yeah, do you guys have any more questions before I wrap this up?
No, I really enjoyed it. I really enjoyed your presentation. It was fantastic.
Same, very passionate.
Yay! I could talk about this for days. I'm kidding. So everyone that's kind of tuning in out there, either live or you're on a replay, thank you so much for being here. Please reach out if you have any questions, you want to collaborate. I am all about it. I'm going to add Elijah, Kristen, and Danny's information into the description notes for this video so you can connect with them too. They are amazing and I can't wait for you to connect with them. But you'll see my Twitter, my hashtag, and my email on here. I also have a website. It's expeditionschneckser.com. I know it's a tricky last name, but you know what? I feel like you'll never forget it. It's kind of like sneezing, like Schneckser. Oh, bless you. So with that, my friends, I hope you have an amazing rest of your day wherever you are. And I hope to catch you on the internet soon.
Awesome.
Thanks for having us, Becky.
Yeah, thanks for being here.
Bye, Becky.
See ya.